Welcome back. In lecture 7, we will complete the theoretical foundations that we started in the previous lecture. The different concepts that would be covered in this lecture are on spatial interaction theory, accessibility-based location models, and then social theory. The spatial interaction theory is basically where we talk about spatial interaction amongst human beings, and many of the classical land use models are based on this particular theory. And it says that human activities require spatial interactions, or we can also call them trips, to cover the distance between the different activity locations. And that is what spatial interaction is all about. And this could be explained using Newton's first law, or the gravity model, which says that the interaction between two entities depend on their own mass and is inversely proportional to the distance between them. So this is a departure from the location theory, which was only focused on determining transportation cost, and also from the bid rent theory, because it was talking about the rent that could be a farm would pay because of the distances and because of its distance from the center and so on. So here in Newton's gravity model, it says that the amount of interaction between two entities not only depends on the distance, which is inversely related of course, but it also depends on their own mass. That means that depends on the size of those two particular entities. So this concept has been applied in studies of migration by Ravenstein and trade by Rayleigh in long back, and we can say that in case of migration, bigger cities attract more migrants as per the law of the gravity, that it depends on the own mass. So bigger mass, bigger would be the migration. And also migration increases when the distance between two areas reduces. That means if the rural area is very near to the city, there will be more migration. So because distance is inversely related with the amount of interaction. While the gravity model was the first spatial interaction model, this spatial interaction model could be also transformed into a location model. And this location model is where, and the work by Alan Wilson in his entropy maximization model, actually a gravity model was given a formulation like a location model. Or he said that 4 types of urban spatial interaction are possible. And for example, there could be a unconstrained model where households are without any fixed residences and jobs. There could be a production constraint model where jobs are not fixed. There could be attraction constraint models where households are searching for residences, and there could be a doubly constrained model which is similar to transportation models with fixed origin and destination. Now, basically, here what in the entropy maximization model, Wilson introduced a balancing factor in addition to the normal gravity model equation, and there we can see. So in a normal gravity model, we can see only this part. That means there is origin or there is destination. That means number of, the size of the origin, the size of the destinations, and then total, the Cij is the cost or impedance for travel between these two destinations to these 2 points, and it is not taken directly. We take exponential of the distance, and we take and because it is inversely related, so that's why a negative sign is there, and beta is a parameter indicating the sensitivity to the travel time or travel cost. So beta is the parameter which we actually can calibrate or change to fit the models. And here you can see this a new part, this AI is introduced, which is the balancing factor, which ensures that total trips equals OI, that is summation of Tij is equal to OI. Now OI are trips generated by total number of trips generated by I, or we can say total number of residences that are there in I, that is we can say Dj are the trips attracted by I, which could means that dj is the number of jobs that are there. So that so in that way we can also say that if I fix Tij, that means if I know Tij, I could also predict the total, the locations of the number of jobs originating, number of trips originating, and number of trips going to a particular zone. We can also predict OI and DJ as well. So that is how the location could be predicted using this spatial interaction model as well. So in a doubly constrained model where we have both the origin and the destination, we know it is there is in that case automatically what we it takes the form of a gravity model. So that means we have a fixed origin, we have a fixed destination. Based on the number of jobs available in the destination, number of trips originating from a particular area, we can determine what is the total number of trips in between this origin and destination. But if we don't know that, that if for example jobs are not fixed, that means we know residences are there, but jobs are not fixed. That means we need to determine where people will go for jobs. In that case, we can use this production constraint model where Tij is equal to Ai into Oi into Dj divided by exponential of the cost of travel. So that basically actually helps us to determine total amount of trips that is going from within these two zones, and we can also determine the probability Pij and using the balancing factor, and we can predict that probability of a trip that goes from I to j is this particular value. So we can see that this is we can also predict the location. If we know that a particular number of trips that are traveling from one zone to another, we can also iterate and see that what sort of distribution of dj will actually support this if I know Oi. So if I know Oi, then automatically dj could be also predicted. So that is how entropy maximization actually improved the existing gravity models, or to be, and also brought it to a form which could be used for determining allocation of people or allocation of jobs in a particular urban area. So using these gravity models, in a famous model by came, which is the Lowry's famous model of land use. It came during 1964. It was developed during 1964. It was called the model of metropolis. In this particular model, two dependent gravity models were used, and both are singly constrained models. So a singly constrained residential location model where jobs are fixed, and a singly constrained service and retail employment location model were nested into each other. That means in the first model, jobs were fixed. Based on that, residences were allocated to different zones of the city, and based on this spread of residences, we had another model which was a retail employment location. So there was one assumption that this particular jobs, residences, when they are locating themselves, they will require retail. So that will lead to some requirement of retail jobs. And when retail jobs are there in certain zones of a city, then how will their employment, or the people who will be employed in those particular retail, how they will be spread across the city. So when this happened, so this is the first iteration. In the next iteration again, we have a new number of residences, and based on that some new amount of retail would be required. So this was iterated till the entire system got balanced. So in Lowry's model of metropolis, it considers both generation and allocation of activities. Both basic industries, that means primary industries, were initially considered. This was taken as an exogenous input. That means so many new jobs are coming to your urban area, and that led to growth of residences, and that growth of residences led to growth of other non-basic sectors or other like retail, and population and service employment was proportional to the potential of each zone. So the term potential is important. In addition to that, a maximum density or holding capacity constraint for each service employment category was also considered, because we cannot have more employment than that is there. So there is a holding capacity constraint. Then population and employment for one particular time horizon was calculated. That means it can only estimate for a particular time period. So it was this is also called static equilibrium. So I will take you through the sequence of this particular model. We have the basic or export sector. These are the sectors which sell their goods and services to non-locals. So that means they are exported outside. So this was derived from forecast from regional projection. So this is an exogenous input. That means this is not part of the model. We take this as an input from outside, and then this led to growth of the non-basic or retail sector. That means this sector actually sell their goods and services to locals, and size and location are determined by size and location of the population. And this includes also government, schools. Those also could be considered as, they are not retail, but they are also the non-basic sectors. And then these are endogenous to the system. That means these are not exogenous, and this could be determined by the model. And then of course there is the household sector, which size is determined by the number of employment opportunities, which includes both basic and non-basic. That means from basic jobs there are certain number of employments that is resulting in, and then when the non-basic jobs came out because of this employment, another set of residences came in supporting these non-basic jobs, and this keeps on iterating, and location is determined by accessibility and particularly to employment. So these are the currently operational land use models such as EMI-Plan, TRANUS, PICAS. These are big land use transportation modeling systems. This currently use this particular concept of allocation, and use the same formulation similar to this Lowry's basic model, and this follows the spatial allocation theory, and we will explain this Lowry's model in detail in the next lecture. So in the last slide, we ended with the spatial interaction theory. So the next theory that comes after this is the accessibility based location models. Now accessibility based location models combines the best of both the economic theory as well as the spatial interaction theory. So the main term that is there in accessibility based location model is of course accessibility. So accessibility can be defined as the opportunity for spatial interactions. That means it could be a distance to a highway or bus stop, or it could be ease of reaching all destinations as per trip purpose or activity. That means for a person, if he is located in a particular area, the accessibility of that area depends on the different activities the person participates in an urban area, and what benefit this area holds in terms of his access to these different activities. It depends on different types of activities. For example, I am going to see a movie, or I am going to a movie theater, then how accessible is this particular zone considering the different movie theaters that are spread around in that urban area. So is this zone near to one movie theater, or it is near to multiple movie theaters? So this actually has to consider the accessibility or the distance to all the different zones which have got a movie theater. So that is why AI, in this particular formula you can see, AI is the potential accessibility of zone I with respect to destination dj, and Cij is the generalized cost of travel between I and j, and here we can see that accessibility is equal to 1 divided by the summation of the potential of all the locations and divided by their distances. So distances of course raised to the power of exponential. So this formulation is similar to what we saw in the earlier slide as well. So this concept of accessibility has been incorporated in several urban land use transportation model systems such as IRPUD, Rarban, Musa, Delta and Urban SIM. So these are again, these are big urban land use transportation modeling systems, and this concept is actually applied in this. And as we discussed, accessibility based location models actually predicts the location choice of households and farms, and this is done using discrete choice. That means using the concept of discrete choice, where last time we were talking about discrete choice in the previous lecture, we said that it depends on the utility of a particular or suitability of a particular area compared to the utility of all other areas, so or all other choices. So here we can say the same concept is utilized, but in one of the parameters, like one of the suitability parameters is of course accessibility. So utility suitability equation can include many parameters. One of the major parameters is accessibility. Then it could be location characteristics of that particular area, means what is the land use characteristics, what is the density and so on, and then household or farm characteristics, that means individuals characteristics of the entity which makes the decision. That the characteristics of that entity also plays a role in determining the utility of that particular choice for that particular entity. So these are the different factors that plays a role. So that means we are incorporating a component of location theory in form of accessibility indicators, and also the concept how it is incorporated is in form of discrete choice. So this is why accessibility based location choice models incorporate both location theory as well as the discrete choice theory that was discussed in earlier lecture. So next comes the social theory, and this includes actually two schools of thought. One is the social ecology, comes from the Chicago school, and the social geography. This two lines of development in this particular theory. And in social ecology theory, urban spatial development results from appropriation of space by individuals and groups, and this follows the theories of invasion, succession or dominance, which is based on animal and plant ecology. What it means is a particular groups migrate in an area, and then that is invasion, and then it succeeds over that particular area, or it can dominate over in that area. So this is the invasion succession concept, and social and economic groups fight for positions in that particular urban system and actually comes to a equilibrium. So this is the social ecology theory, and then there comes the social geography theory, which is more appropriate for urban planning, where it says that a new term is introduced which is called action space analysis. This was introduced by Chapin and Weiss in 1968. This theory says that household daily and weekly activities influences choice. That means the routine schedules that household follow during a particular day or during a week, that actually influences the choice of a particular household to choose a particular location, or for a particular household to go to a movie or go to a school. It will depend on his particular kind of activities, or activity includes both the time when he is doing that thing, where he is, what kind of, who is going along with, and so on. So this changes, and this particular activities or changes also as per the life cycle of the household, and also constrained by income and family size. That means at different life cycle, that means a young person does certain activities which is different from an older person, or a family which is having a of an individual who is married, who has got a household, there are kids in the household. So for them also the activities will vary. So during different life cycles these activity patterns change, and it is also constrained by the kind of income and family size. For example, a poor family will do different activities compared to a rich family, and family size also plays a role. For example, I have got a large family, so when I have got one car, I can only one person can use the car, or maybe two persons can use the car, but not everybody can use the car. But so if the family size was small, probably both of them could use the car, or single person can use the car. So that is how the choices or activities are constrained by incomes and family size. And distance to different chosen activities define the desired mix of accessibilities and the probable location of housing, workplace and shopping. That means if I choose to go to a school somewhere, so that particular activity will decide on where I should locate, or if I am walking at a particular location, this influences my choice, and that means my desired accessibility for a particular location is dependent on my my choice of workplace, housing, and so on. So all these things play a role, and so we can conclude by saying that socioeconomic group-specific activity patterns lead to specific spatiotemporal behavior and hence shape spatial organization. That means the different socioeconomic groups and their different activity patterns, that actually leads to different kinds of spatiotemporal behavior, and that actually this spatiotemporal behavior on the other hand influences the spatial organization of cities. So this particular theory was made operational into a form which could be actually used to determine mode choices or route choices in the time geography theory by Hagerstrand in 1970s, where it says that individual command action spaces of different size and duration subject to 3 constraints. That means one family or a particular individual has got a particular action space. Action space is basically their activity pattern, their time schedule, all these things included. So this could be explained using a 3D space-time model, where space is represented by 2-dimensional plane. For example, this is the urban space and this is time. So we have this 2-dimensional plane over here, and it could be represented by this where space is represented in this particular plane and time is in the vertical axis. So within this you can see that a person has a limited time and time budget. That means he has to perform certain activities within a limited time. Depending on what he chooses to perform, accordingly the activity will, this pattern will vary. For example, a person is having, there are different, this is the location of activity 1, which is home, and he has to go to do activity 2, which is also fixed. Maybe this is job, but in between there is an alternative activity like shopping. Means, for example, from home to a person is going to office, and there in between he will go for shopping, or he is going to drop off his kid to a school. So in this case, if he leaves his home early and he spends certain time at home, and then he leaves for that, and then he goes to activity 2, and then again he spends certain time for activity 2, and then he reaches over here to his activity, the fixed activity, which is work. And similarly, another person can go like this. He goes to another activity, activity 1, then he comes over here to activity 2, there he can spend little time for activity 2, and then he can go to this, the fixed activity over here. So that means depending on what kind of activities a person will perform, his time area diagram will vary, and this is also called a prism. This time area prism will vary. This is called a space-time prism, and this actually also helps us to determine how a person schedules his daily pattern of movement from one zone to another, and at what time, that also is included. So this time geography theory also considers 3 kinds of constraints. One is the capacity constraint, which includes personal, monetary and budget, monetary budgets and so on, which means he may be an old person, so he is not capable to do certain activities, or it's a monetary budget, that means he is not capable because he doesn't have money, he cannot do certain activities. Or it could be coupling constraint, that means he has to do joint activities with other individuals, that means he has to take his kid to school. So that is, that has to be done together. So the choices will be dependent because both the persons are going together. So if he was going alone, he could have taken a cycle, but because he is taking his kid, he will take a car. So that could be, that is how coupling constraints also play a role. And then comes institutional constraints like the total, like when the office opens. Like if I go to the office when it is closed, there is no point, or similarly, if I go to a movie when beforehand, there is no point of going there. So that also determines the time when I choose to travel for that particular activity. So to summarize, I can say that individuals, if I look at this space-time prism, individuals maximize activities or opportunities contrary to the earlier belief that individuals minimize travel time or cost. So that means in the location theories, even in, when we are talking about this gravity model, the time was always taken having a negative, it was negatively influencing the travel, the interaction between two different entities, or location choice of industries or individuals and so on. But here it talks about that it's not, we are not trying to minimize the travel time or cost, but we are trying to maximize the kind of activities or opportunities that comes in, that a person can undertake in a particular day or a particular week, depending on what scale we are talking about. So that means the focus is on activities or opportunities and not on the travel time. So that means if I can maximize the number of activities, that then time doesn't play much role. So this is the time geography theory, and this is a departure from the earlier models, and this theory is the basis of the basis of activity-based models of land use transportation models, which are currently being developed. So this is a totally departure from the previous models, but so more or less these are the three theories, but this theory is still under this activity-based models are still under development. So our course will mostly focus on the previous two theories during the different models that we will build. So to conclude, we can say that while many of the spatial interaction-based land use transportation models are still operational, accessibility-based location allocation models are the most popular. So accessibility-based location allocation models are mostly because they cover both accessibility as well as the location theories to certain extent, and also the economic as well as the gravity model to certain extent. That's why they are the most popular, and they are more robust also. So because this models also allows much more flexibility in terms of policy analysis, and also allows us to incorporate the heterogeneity in terms of population characteristics. And in recent years, social theory based models, also known as activity based models, are also gaining popularity. So that is how these different theories actually influence different land use transportation models, or the structure of land use transportation models in urban areas. Thank you.